Assalamualaikum and hello everyone. My name is AINAA. Today we are going to learn inertia in 15 minutes. Are you ready? Okay, let's start our class now. Let us first check the learning standard that you should have to fulfill for inertia. By the end of this lesson, you should be able to explain with the example the concept of inertia. Second, carry out an experiment to find the relationship between inertia and mass. And then the third one is justify the effect of inertia in daily life. So, let's begin the inertia with this example. Look at the picture. What did he do? Figure 1 shows an entertainer jerks a tablecloth without moving the object on the table. Why does this happen? This will bring the idea to the concept of inertia. So, what does inertia refers to? Inertia refers to the tendency of an object to remain at rest or, if moving, to continue its motion in a straight line at uniform velocity. This inertia can be explained from Newton's first law of motion, where it states that an object will remain at rest or move at uniform velocity unless acted upon by an external force. Next, we move on to demonstrate the concept of inertia. To do this activity, we must have all the materials first. We need a glass filled with water, coin, and a thin cardboard. And then we need to set up the activity. First, arrange the material as shown in the figure above. Next, jerk the cardboard under the coin horizontally. Okay, now why the coin not moving with the cardboard? Since the coin is initially at rest, the inertia of the coin maintains its state at rest. When the cardboard is pulled away, there is nothing to support it. The coin falls vertically downwards, which is into the glass due to the gravity. And this is another example of inertia. Look at the white car. The white car is initially at rest on the tow truck. When the tow truck moves in a sudden, the car remains at its initial position. The inertia will keep it remain at rest, so it will fall off the truck and fall down exactly where the actual point is. Look at the next example. It is about tennis balls who are initially at rest. Since the tennis balls are initially at rest, their inertia maintains its state at rest. When the cardboard is pulled away, there is nothing to support them. The tennis balls fall vertically downwards, which is into the glass due to the gravity. Move on to the next example. A stack of blocks is being swiped away by the woman. Initially, all blocks are at rest. When she swipes the bottom blocks, the above blocks will not follow the movement. The inertia of the blocks above keeps them in their original position. The above blocks will fall vertically on top of the table. Now, look at the jumper. The jumper is initially moving. When he landed on the sand, he will not stop immediately. He will slide forward due to inertia, continue moving forward. The last example shows a moving Newton's cradle. If there is no force to stop the Newton's cradle, it will keep moving forever. Now, we are going to look at the factors that affect inertia. From the picture, what can you see? Yes, the mass of the elephant and the boy is different. How about this picture of bowling ball and the football? Yes, the mass of bowling ball and the football is different. So, what can we conclude from this? Yes, good. The factors that affect the inertia is mass. Now, let us recognize the relationship between inertia and mass. Let's look again to the picture above. What happened when the person hit the elephant? When the person is running and hit the elephant, it is easy to stop the person, but very difficult to move the elephant, which is at rest due to the bigger inertia. Let's look once again to this football and bowling ball. Which ball is difficult to stop when in motion? An object with a bigger mass is more difficult to set in motion or stop from moving as compared to a lighter object. Okay, now let's move on to the second learning outcome, which is carry out experiment to find a relationship between inertia and mass. The aim of this experiment is to study the relationship between inertia and mass. The apparatus needed for this experiment is stopwatch, G-clamp, ruler, and jigsaw blade, and the material needed is a plasticine with mass 20 gram, 30 gram, 40 gram, 50 gram, and 60 gram. So, this is how we set up the experiment. First, clamp jigsaw blade with G-clamp to the table. Second, attach plasticine with mass 20 gram to free end of the jigsaw blade. And then use stopwatch to record the time taken for the plasticine to make 10 complete oscillation, T1. Next, repeat steps 3 and 4 and record the time as T2. Last but not least, repeat steps 2 to 5 using plasticine of mass 30 gram, 40 gram, 50 gram, and 60 gram. So, this is the graph you will get after plotting the data. This graph of T square versus M shows a straight line passing through the origin. This means that the period of oscillation increases with the mass of the load. Based on this experiment, we can conclude that the object with a large mass have a large inertia. We move on to the last learning outcome, which is justify the effect of inertia in daily life. The first situation shows the raindrops spawn off when a wet umbrella is rotated and suddenly stopped. Raindrops on an umbrella are in motion as the umbrella rotates. When the umbrella stops rotating, the inertia of the raindrops causes the raindrops to continue in motion and leave the surface of the umbrella. Next, look at the picture. Passengers are thrown backwards when the bus at rest suddenly starts moving forwards. The next picture shows the passengers are thrown forward when the moving bus suddenly stops. The inertia of the passengers keep them in their initial state of rest or motion. The third situation is about chili sauce. Chili sauce or tomato sauce in the bottle flow out when the glass is moved quickly downward and then suddenly stop. The inertia of the sauce causes it to continue moving downwards and out of the bottle. Next, the picture shows an oil tanker. Oil tanker trucks have large inertia. In fact, an oil tanker truck has its storage tank divided into several separate tanks. The separated tanks reduce the impact of the inertia of the petrol. Last but not least, driver and passengers of a car are advised to wear seat belts. When a car stops abruptly, the driver and passengers in the car are thrown forward because of inertia. Seat belts prevent them from being thrown forward and hurting themselves. This is a question related to inertia. Look at the picture. Why a car with higher load is more difficult to be controlled? This is because with more passengers, the mass increase and hence increase the effect of inertia. This makes the car more difficult to change its speed, more difficult to stop, and more difficult to change in direction. Next, diagram below shows water flowing out of a tank from a moving lorry. what happens to the inertia of the lorry? This is the optional answer for the questions. So, what happened to the inertia of the lorry? The answer is B. The inertia of the lorry decreases. When the water flows out from the tank of the lorry, the mass of the lorry decreases. Thus, the inertia of the lorry also decreases. Alright, that's all for today. Thank you for watching. Bye.